In triad exercise 3 of section 8.6, we are asked to solve 3c squared equals 10c minus 8. Eventually we're going to use the zero product property again. In this case, we want to put it in quadratic form. The y equals ax squared plus bx plus c, or ax squared plus bx plus c equals 0. We want this form. And then we'll factor. So we have 3c squared on the left side. Let's go ahead and move everything to the left side. So 3c squared, subtract 10c from both sides. We get 3c squared minus 10c, and then add 8 to both sides. So plus 8 equals 0. So now we have this in that quadratic form. 3c squared minus 10c plus 8 equals 0. And now we need to look at, will this factor? Right now, because of this particular section and example, we know this will factor. Later on, you'll have to figure that out in order to solve the quadratic. So we know that with this leading coefficient 3, that the only factors of 3 are 1 and 3. So we know this is going to be 3c and c. Now we want some combination. We know that because 8 is being added and 10c is being subtracted, we want two numbers that multiply to 8, or two numbers that multiply to a positive and add to a negative. So if we try, let's say, 3c minus 2 times c minus 4, well, what does that end up giving us? That ends up giving us 3c squared minus 2c minus 12c, or minus 12c minus 2c if we're going outside than inside. So that means that would be negative 14c, so that's not going to work. So we know that's not going to be the two values. Now what if we switched those around? 4 and 2. And again, we know they're both going to be subtracted because we're adding 8. So we want something that multiplies, two numbers that multiply to a positive number that when added along with the coefficient on c, the 3, ends up being a negative. So what do we end up with if we multiply this through? We have 3c squared. Outside would be minus 6c minus 4c, which is minus 10c. And then we know that they multiply to 8. Negative 4 times negative 2 equals 8. So we found our factorization. 3c minus 4 times c minus 2 equals 0. And now we're back to the same old problem of using the zero product property. We said each of the factors equal to 0. 3c minus 4 equals 0, or c minus 2 equals 0. Add 4 to both sides of this equation, we get 3c equals 4. Divide both sides by 3, and we get c equals 4/3. Or if we add 2 to both sides of this equation, we get c equals 2. So here are tentatively our two solutions. Let's go ahead and check. We'll substitute those into our original equation. Let's start with c equals 4/3. So 3 times 4/3 squared. We want to know, does that equal 10 times 4/3 minus 8? So 3 times 4/3 squared is 16 ninths. Does that equal 40/3 minus, let's go ahead and make this 8 times 3 is 24/3. So 40/3 minus 24/3. That's why we have a common denominator. And that ends up giving us 16/3 because 3 divided by 3 is 1, 9 divided by 3 is 3. So when we simplify, that's 16/3. Again, we should have a question mark here, I guess. And then 40/3 minus 24/3, that is 16/3. So that does check. So our first solution checks. What about our second solution of 2? 3 times 2 squared. We want to know, does that equal 10 times 2 minus 8. So 2 squared is 4, 3 times 4 is 12. 10 times 2 is 20, minus 8 is 12. 12 equals 12, so this does check. So our two solutions are c equals 4/3 and c equals 2. And again, anytime we have a quadratic like this where the variables on both sides of the equation, we have anything on the other side of the equation, a constant as well, we move everything to one side of the equation to put it in quadratic form. So that was our 3c squared minus 10c plus 8. Then we factor, and then we use the zero product property to set each of those factors equal to 0, and then solve for the variable. And then to check again, we just substitute back into the original equation and make sure that it makes a true statement.